Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to continue with our chapter 3.1 to 3.4 review. This is from Algebra 1. This is the Big Ideas review. This is, again, just a review sheet that I received from a couple of students. We were talking about it, and I wanted to make sure that we understood it fully. So here you go. So this is day 2. Don't forget to find where day 1 is and go ahead and take a look at day 1. If you want to see more videos like this, please definitely feel free to reach out to me and submit a review sheet that you want me to go over and explain. So without further ado, we're going to continue. It says, which of the following is a function? So again, my graphs don't look exactly the way that they do on this review sheet, but definitely it gives you an understanding of what things belong, of how they look. So one of the things that I'm going to do for graphs, and every time I have a graph, I'm always going to check based on this vertical line test. So this is like a really large line. But what we're going to do with this vertical line is we're going to actually go in for problem A, and we're going to see, does my vertical line pass through any of these points in 2 places, right? So for example, here's 1 point, 1 point, 1 point, 1 point. So that means to me is that, yes, this is indeed an actual function. So which of the following is a function? This is a function. Let's take a look at B. Oh my goodness, all of a sudden I have it hit here and here. So this is not a function. So we will not be selecting this as an option. From what I understand, this seems to be like a multiple choice question on this problem. So you have the ability to pick and choose. So I'm just not going to pick it. This is not a correct answer. Let's go ahead and let's just finish with the graphs first, and then we'll go in. So in here, I had a random selection of points. It does pass my vertical line test. None of these points go through more than once on my vertical line. So yes, this is a function. Another way that I can be asked, hey, is something a function? Is if I have a set of points. Now, a set of points can look like problem C, a set of points can look like an input-output base, and a set of points can look like one of these input-output. So right away, visually, looking at F, I know that this is not a function because the number 2 has 2 possible outcomes, right? So if I were to go ahead and if I were to graph that particular piece, I would go in and I would say, okay, 2 is 0. So here's 2, 0. And 2 could be 1. So here's 2, 1. Obviously, this would not pass that vertical line test because I would have 2 points on that same vertical line. So this is also not a function. This is also not a function. Another way that I can take a look at these is by taking a look at all my x values. If none of my x values repeat, like they do not here, right? There's a -2 and a +2, but it's not the same 2. There's a -1 and a +1. It's not the same one, right? So therefore, we know that this is totally a function. So we can go ahead and we can just circle this up and say, yes, none of my x values repeat, therefore it is a function. The same thing is here in my input, none of my x functions repeat. So then yes, this is totally 100% a function. This is exactly what we're looking for. Okay, let's continue. So now they ask us again, determine if this relation is a function, and it does say to explain. So my thought process is they do want at least a sentence or so that you can explain why you think, yes, it is a function, why you think, no, it's not a function. So again, what we're going to do is we're going to take a look at these particular x values. So I have -2, -1, 1, 2, and 3. Well, if my x values don't repeat, then 100% this is a function. So I'm going to go ahead, I'm going to come in here and I'm going to, oh, where's my thing? Okay. So yes, this is a function. This A. This is a function because none of my x values repeat. And that's literally all I would say, because none of my values repeat. Okay. Here in this case, it's a little bit easier to see what my inputs are. And because it's easier to see what my inputs are, then I know right away that none of these guys repeat. And so therefore, again, I would say, yes, this is a function, but in this case, I would say, not because none of my x values repeat, I would replace x with input values. Same exact set of words, but instead of x, it would be input, because here I have x, y values, right? And in here I have input, output values. So that's where the difference is. So this I would say, yes, da-da-da-da-da. Okay. And honestly, as a former Algebra 1 teacher, I would totally accept this as an answer. That I wouldn't desire anything more, nothing less. This is a function because none of the values repeat. None of the, whatever the input or x values repeat. All right, so here we're asked to evaluate. Now, because we're given x is equal to 3 different types of values, we can do a couple of things. So the first thing that I like to do is, because I think in tables, I think in like first, the second, third, right? So I would recommend going in and saying, hey, my g of x is equal to -4, but I would put it in a slightly different. So here are my x values. Here is the function that I am looking at, and here are my quote unquote y values. So we talked about anytime we have something like this, it's the same thing as y. So I can almost replace it as y, but since they give me g of x, we're going to leave this g of x. Okay. We're going to put in place of x -3, 0, and 1. Whoa. Okay. Okay. And so I'm going to do -4 times -3. That's going to be 12. -4 times 0, 0. -4 times 1, -4. So I can go in and I can leave my answer as is, because your teacher will see these. If you want to circle them to like bring it out and say, hey, this is the actual answer, great. You can also do fancy brackets, which I clearly cannot draw anymore. I don't know. And I would put in 12, 0, -4. Some teachers would prefer for it to go from negative to positive. So from least to greatest, you can definitely do it in ascending order. But I would somehow make sure that you know, or that you make known to your teacher that -3 relates to 12, 0 relates to 0, and 1 relates to -4. So I think this stuff might be a little bit extra. So I don't know that it's an absolute necessity. I think this is totally fine. Another way to go about showing work like this is, and I'm going to change my color just so that we see, is instead of writing f of x, I'm going to write f of -3. And then I'm going to write f of 0. And then I'm going to write f of 1. So I'm going to go in -5 plus 5. And every time I see my x, so if it appears multiple times, I'm just going to replace that x with this -3 here. So -3 minus 7. -5 plus 5 times 0 minus 7, and -5 plus 5 times 1 minus 7. Now, because there's a lot of numbers going on in here, I would recommend definitely taking it a little slower than usual. That's one. To make sure that you're writing the problem down correctly and you're writing the actual x values down correctly. Because I've seen when students like forget this negative, right? And it's like, oh, whatever, it's just 3. Well, okay, but it's not really just 3. So you're going to end up with an incorrect answer. So our goal is to have correct answers, but we don't want our mistakes to be super silly. Okay. So we're going to have -5 minus 15 minus 7, which gives me -20 minus 7, which is -27. And then I'm going to have -5. Well, this is 0, so I just don't even need it. minus 7, which is negative 12. And then I have negative 5 plus 5 minus 7. These guys cancel each other out, so just negative 7. Again, you can go ahead and just circle the final answers so that your teacher knows, hey, these 3 x values represent or correspond to those 3 y values. Okay? Then we're asked to graph the functions. So I feel like we've done these in the first video. In the first video, they were more multiple choice questions. Here, you're actually asked to do like a short answer, like a graph, an actual graph. So I go in and I say, okay, here's my x, here's my y. I find where y is 2. And then I go in and create a solid line for y equals 2 all the way across. Every single point on this graph is going to have y equal the value of 2. So then let's take a look at, oh yikes, let's take a look at our x and y values here. We want x to be negative 2.5, so we know the negatives are on this side. So I'm just gonna label it negative 2.5, and I'm gonna try my best to create it as parallel as I can to the y, but also in this kind of like perpendicular angle. Obviously, it does not quite look as parallel as it should. Whoops, can we do that maybe? Well, that's a little bit better. Well, yeah, I don't know how much better that really is, but here we go. That's kind of where we're at. We're looking at this kind of arrow here and here. And that's it. That's all you need to do for those 2 problems. So then we're asked to use intercepts to graph the function, and we're asked to label the points. This is the first time on this review sheet that we're asked to label points. Up until now, we haven't been asked to, and we have not been labeling points, and neither have the problems. The problems have not labeled any points either. So if we need to use the intercept to graph the function, that means we need to first find the intercepts, right? So we need to figure out, where does my graph hit the x-axis and where does my graph hit the y-axis? In order for me to do that, I want to make sure that I fully understand what happens on the x and y-axis and when things are intercepts. This is considered a y-intercept. In here, my x value is 0 and my y has some sort of number. Let's put in just a y value. In here, this is an x-intercept. In here, my x has a value, but my y is left as 0. So when I look at my function, instead of rewriting it so that I can get this y equals mx plus b format, which we talked about in the first video, this time we're going to use these intercepts to really help us find just 2 points and connect those 2 points, okay? So in order to find the y-intercept, my x value has to be 0. So I'm going to replace my x with 0 and solve for y. Now that I only have one variable, it's super easy to solve for it because I know I just get everything all over to the other side of where my variable is. I also know that anything times 0 is 0, so this is kind of like goes away. So I'm really left with a one-step equation to solve, right? I know I divide both sides by -7, and I end up with y is 5. This is an important piece of information for when I graph my graph. Then I go and I need to find my x-intercept, right? So because my x-intercept has a value, but my y is 0, I'm going to go in and say 5x minus 7 times 0 minus 35. And I'm going to end up having this, again, this is 0. Now I have a 1 variable and a one-step equation. Divide both sides by 5, x is going to be -7. Now that I have these 2 pieces of very important information, I can go in and graph my graph. So here's my x value, here's my y value. I find 5 on the y, and I find -7 on the x. That looks like a weird -7. And I know that these are both my intercepts because that's what I got here. And then I just, well, kind of make a not not a wavy, curvy line, but you get the idea. I feel like every time I graph graphs, either I need to have just let it go and be, hey, these are curvy, these are wavy, or actually use the arrow or the straight line tool on my program. It is what it is. On your end, I do strongly encourage using a ruler. Rulers are super helpful and super, super important, especially when you are looking at, from the teacher's perspective, does my student know how to create a straight line, yes or no? Can the student use tools surrounding tools to create what they need to create, yes or no? That's kind of where we're at. Okay. So now let's take a look at the next one. So I'm going to change my color a little bit. Again, the same business. I want to know what my X value is. I want to know what my Y value is. So I'm going to create X plus 3 times 0 equals 6. And Y plus, 0 plus 3Y equals 6. In this case, I know that this is 0. So X must be 6. And well, that's 0. So then I would just divide by 2 on both sides and by 3 to get Y equals 2. I've also known to do that, give away answers before I actually put them down. It's really fun in the classroom when I tell the kids hey, you know that this is 2, right? Because anyway, they don't get a chance to answer. So we know that X is 6, so we're going to find 6 on the X axis. We're going to create a point right here. We know that Y is 2. We're going to create a point right here. And then we're going to go in and graph this graph. And that's my graph. That's all it is. Now, the other piece is we wanted to label the points, right? So this is something that I kind of forgot in the first problem. I want to make sure that we rectify it before we move on. Since we know that all of our y-intercepts are zero-sum number, this point is going to be 0, 5, this point right here. We also know that this point is going to be some number 0, so -7, 0. If I were giving this as a test, and if I were testing this on a set of Algebra 1 students, and my points were not labeled, but the instructions did state to label the points, I would definitely give points off for that. Since the instructions stated label the points, you absolutely must label the points. So another piece of helpful information in this particular case is read exactly what the instructions say. Make sure you underline, highlight, bring to attention, hey, this is important. This is what I need to do. This is what the question is asking me. I need to answer it in full. Because let's say these 2 questions would probably be worth 4 points. I would give a point for Y equals, a point for X equals, a point for each of these values, and the fact that they're labeled. So this, you would get 50% if you didn't label the intercepts. So we don't want to lose points for that, just because that's silly, right? Okay. So now we're at a point right here. It says the function n equals -b plus 30 represents the number of eggs, which represents n, and then the number of eggs that are left in the carton after making B breakfast sandwiches. So they want us to label the dependent and independent variable. So the independent variable is always on its own. It's separate, and no one cares about what no one can say, yes, this is something depends on it. It's independent. It's on its own, right? It's an independent woman, or whatever that song is. In here, my independent variable is always going to be, let's backtrack for a hot second. I have y equals mx plus c, right? This is something that we've learned in the past, right? And we know this to be a true statement. We also know that our x variable is always an independent variable. The reason why it's independent is because we need to put something into x in order to get our y value. Why is this relevant? Why is this important when we're looking at n equals negative b plus 30? Well, this is how many eggs I have, right? So this is how many eggs are left. After I make breakfast sandwiches, so if I'm looking at how many eggs I have left, I need to know how many breakfast sandwiches I've made, right? That means my breakfast sandwiches, my B, my sandwiches, are going to be completely independent of the amount of eggs that are left, okay? My dependent variable, the variable that depends on the other one, is n for my number of eggs or my eggs left. Okay. Now they're asking us for, hey, this is the domain. What's my range? So again, I can do a couple of things. I really like this table of values that I had over, oh, just kidding. This table of values that I had over here. I think it's very organized, very clean cut. It's one of my favorite methods, one of my favorite ways to solve a problem. I can also do this as well, not an absolute necessity. So if my domain is 1, 2, 3, and 4, and I know that my function is n equals negative b plus 30, what is my range? That's what they're asking us. So I know that my domain represents my x, my independent variable. So my domain is going to be b. My range will be n. So I'm going to have negative 1 plus 30, or negative 2 plus 30, and negative 3 plus 30, and negative 4 plus 30. Basically, I'm using an egg every time I make a breakfast sandwich or something along those lines, right? So after one sandwich, I have 29 eggs, 28 eggs, 27 eggs, and 26 eggs. Again, one of the things that you can do is absolutely either just highlight, or I don't know if you're allowed a highlighter on tests or not, but somehow make it visible that that's your range and that your range looks at these values for the domain. Okay, so this is the end of the second video out of 3. We still have one more that talks about domain and range with lots of different graphs, okay? So I will see you in the next video. Bye.